Okay, so what you've got so far is this question. I don't know what the problem is, but with these types of question, Elias, all you've got to do is make sure that you've got you convert everything into vector format. Okay, so that's the positive y-axis or J direction, and that's your I direction. So if we're going to look at this, I'm going to say that our vector for our impulse is equal to, well, that's 90 plus alpha all the way around here, so that's alpha. You're also told in the question that tan alpha equals 3/4, and you've got that is opposite over adjacent to 3, 4, 5 triangle, and therefore you know that the component, horizontal component, that's positive I, that's negative I, it's negative, and it's 12.5, and it is sin alpha. And then the bit in the vertical direction is a positive direction, it is 12.5, and it is cos alpha. It's that many Newton seconds. So my advice is always to deal with these questions is to convert them into vector format. Okay, now you know that sin alpha is equal to opposite over adjacent, so that's 3/5. So you're going to end up with 3 times 12.5 divided by 3.5 divided by 5. So quickly work that out. So you've got 12.5. What do I say? 3/5, 6. Okay, so it gives you minus 7.5. You've got this bit here, which is cos, which is going to be 4/5. That's times by 0.8. So 12.5 times by 0.8 equals, and that gives you 10. I'm pressing that right hand button. So that's what we get. That's the new impulse in vector format in Newton seconds. The initial velocity u is equal to, well, that's just simply going horizontally, so it's a positive 30, and it's not, there's no horizontal vertical component, so it's that many meters per second. And then we're just going to use the normal format for impulse is equal to mv minus mu. Well, because the mass is the same, I'm just going to do v minus u, and this is all direction important. So you've already got it in vector format, so we haven't got to worry about the directions now. The impulse is minus 7.5. Keep on doing that. Minus 7.5, 10, and it is equal to 1/4, which is the mass. Okay. Final velocity, which is what we're trying to find, so v, minus u, which is 30, 0. Okay, and from there, I'm going to times everything through by 4, so times that by 4 and that by 4. So that's going to give you minus 30 on the top and 40 on the bottom, is equal to v minus 30, 0. I'm going to add that to both sides, throw it over. So v actually becomes 0, 40. And that's a vector, but we don't want a vector. We're going to modulus it, but you can see that's only got one direction, so we can say therefore the speed is 40 meters per second, and it is perpendicular, because it's what that means, because you've got to give a direction to it. It means it's actually going upwards like that, 40 meters per second. So we need to say that therefore speed is 40 meters per second, perpendicular, perp to x-axis or horizontal or original direction, perp to original direction. Okay, now to get the direction it's travelling in, okay, so we know it's travelling up there like that. The next question says what's the direction? Well, I've covered that actually, so straightforward. It's actually going, the final velocity is telling you where it's going, and it's travelling vertically upwards, so that's part A and B. I don't know what the problem with there was. It's a typical thing. I'm sure I've shown you how to do those recently, so I hope that clears that up. Okay.